My dear students, now we are going to look at an arbitrary count sequence counter, which is up counter. The arbitrary sequence given to us is 2, then 4, 5, 6, okay, 8 and 10. Now out of this, if at all I look for what is the maximum value that exactly we have a count value. The maximum value of count is, say, okay, 10. So to represent 10, how many flip flops required? 10 is 1010. So the number of flip flops required are 4. Okay. So with 4 flip flops we need to work with. Okay. So we take 4 flip flops, then it can be of any 4 flip flop, like any, in the sense it may be SR, it may be JK, it may be D, or it may be T flip flop. So now what we try to do is we will take up, okay, T flip flop. So in the step 1, what we have seen is number of flip flops required. So the number of flip flops required are 4. Number of flip flops required are 4, of course. Okay. So are we going to use n greater than or equals to capital N? No. It's not a mod counter. What is mod n counter? If I say mod 4 counter, it will start from 0 to 1, 1 to 2, 2 to 3, then back to 0. But it is an arbitrary sequence. So for arbitrary sequence, what we try to do is we try to see the maximum number. What is the maximum value in the given number? Is 10. So how many flip flops required to represent value 10? 1010. So 4 flip flops. Now which flip flops that you want to use? Let's say T flip flop. Then what exactly the state diagram? The state diagram is based on what exactly the sequence that we want. The sequence that we want is 2, 4, okay, then 5, 6, 8 and 10. So if the present state is 2, from there it will go to state 4. From there we will go to state 5. From there it will go to state 6. From there it will go to state 8. From there it will go to state 10. From there it will go to state 2. So it is gone repeated, right? So this we will represent in a state diagram. Okay. So the state is represented in a circle. So 2 is 0, 0, 1, 0. Next is from 2 to what exactly? 4. From 4 to 5. So 0, 1, 0, 0. Then what we try to do is from there it will go to 5. Okay. 0, 1, 0, 1. From there, let me write properly. 0, 1, 0, 1. Then 5 to 6. So 0, 1, 1, 0. 6 to 8. So 0, 1, 0, 0. 8 to 10. 1, 0, 1, 0. From 1, 0, 1, 0 to. So this is what exactly the upcounting sequence. Okay. This is what exactly known as state diagram. This is what exactly our flip flop should be able to produce. Right. So from this, what is clear is there are unused states. What are they? Undefined or unused states. So if you look at the 2, 4, 5, 6, 8 and 10. Totally we have only 6 states with which we are working. For a 4 flip flops, the inputs possible as, like, we can store from, we can have the contents of memory in a counter 4 zeros to 4 ones. So in this we will be having 2 power 4 combinations, total 16 combinations. For 6 combinations only we have defined next state. Okay. For 10 combinations there is no defined next state, so we will consider them as don't cares. Okay. So that is what exactly that we are going to look into it, which is known as excitation table for this arbitrary sequencing counter, okay, which is up, counting up in nature. So the present state is let's say the flip flop A, B, C and D, and the serial numbers as written here. Now we are going to get next state QA plus 1, QB plus 1, QC plus 1, QD plus 1. Then inputs are TA, TB, TC and TD. Okay. Now what I need to do? What I need to do is, for the cases where there is no next state, for 0, 0, 0, next state is doesn't matter. Okay, it's not defined. So what we try to do is we will call it as don't care. So only for the states which we know, for 2 the next state is 4. For 3 there is no next state defined. For 4 the next state defined is 5. For 5 the next state defined is 6. Here is 6. Likewise, for 6 the next state is 8. For 8 the next state is 10. For rest all, you can see. Okay. For 10 the next state is 2. So for example, for 10 next state is 2. For rest all, okay, don't care. Right. So wherever the next state is don't care, so T input is also don't care, because what next state you want to go is undefined or doesn't matter, and obviously input also doesn't matter. So only thing is, for the 6 different cases I need to write the inputs. So what I try to do is, just we'll try to make a comparison and we try to fill it up. When it is 0 and 0, so it is 0. Okay. Similarly, when this is 0 and this is 1, so input is 1. When this is 1 and whereas this is 0, 0, 1 or 1, it is 1. Okay. Next it is 0 and whereas this is also 0, so it is 0. Fine. So next what we try to do is, for 8 next state is 0. So 8 next state is 10, so this is also 0. So when you compare this 0 with this 0, okay, so we are going to get once again 0. Okay. So next what I need to do, I need to compare QB plus, so when this is 1 and it is 0, so it is 1. So this is next is not there, here it is 0, here it is also 0, so it is 0. So here it is 0, it is 1, so it should be 1. So it is 1, whereas this is 0. Okay, it should be 1. Then when this is 0, here it is 1, so it should be 1. Okay, when it is 1, it is also 1, so it is 0. Okay, next we will look for, okay, every time I need to look for 6 different cases, right? So 6 cases I need to enter. Rest all or don't cares for TA, TB, TC, TD. Now if I compare this 0 with this 1, so 0, 1, so input should be 1. Then it should be 1, it is 1 and it is 1, so 0. Next 1, then 1, so 0. 1, this is 0, 1, 0 is 1. Similarly, what I need to do, I need to look for the case 8. So when it is 0, this is also 0, so it is 0. So when it is 0, it is 0, so it is also 0. Okay. So when it is 1, this is 0. Okay. So it should be 1. Then it is 1 and it is 1, so it is 0. Whereas this is 0, this is 1, so it should be 1. It is 0, this is also 0, so 0. 0, 0, it is also 0. Okay. QD and QD plus 1 is compared. So this is 0, this is 0, it is also 0. Okay. Now what we need to do is, we need to write the expressions for what? For TA, TB, TC. So what is common in these things is, let us write the don't care terms. So don't care terms are 0, 1, okay, 0, 1, then 3, okay, then 4, 5, 6 are not there, 7, 9, 7, 9. Once 9 is done, then 11, 12, 13, okay, 14 and 15. So 6, we have only 6 states being defined and rest of them. So there should be 10. So 5 on the top, 5 on the bottom. Totally 10, don't care, sir. That's fine. Now what about TA? TA is 1 for what? Exactly 4. So sigma m, it is 1 for 4, 1 for 5. Is there anything more than that? For 4 and 5 it is 1. Okay. Next, what exactly TB? This is for TA. Let's look at for TB. TB is nothing but sigma m. What are the values I am going to get for TB is, it is 1 for 2, it is 1 for 2, 1 for 5 and 6, 5 and 6, then 8, 5, 6, 8, okay, 2, 5, 6, 8, 2, 5, 6, 8, okay. Next, your TC is 1, which is sigma m. 1 for what? TC is 1 for 2 and 6. 2, 6. Don't cares are common for everyone. So for next is TD. So TD is nothing but sigma m. It is only 2, 6. And here it is 6, 10. So it is 6 and 10. So 6, 10. With this, what I try to do is, I try to simplify this. So now I have, this is my QA, QB, QC, QD. So what I need to do? It is don't care for 0, 1, 2, no not 2, 0, 1, 3, don't care terms are 0, 1, 3, 7, 9. So 0, 1, 3, 7, this is 7, this is 9, okay. Then 11, 12, 11. So your numbers will be, this is 11, okay, 11, 12, 13, 14 and 15. Putting all together, it should be, how much it should be totally? 10. So how much should be vacant? So this is 4, 4, 8 plus 2, 10. So that's fine. So next what is required is we need to enter the values of TA. TA is 1 for 4 and 5. It is 1 for 4 and is 1 for 5. Okay. So what I can do is, I can take this 4, not required. So simply I can go for simple expression like this. Okay. So my TA is nothing but, what is my TA value now? Now it is QD bar and QB bar. So QD bar and QB bar.